There are some health and safety regulations that you must pay attention to when participating in any virtual event. Please make sure that you wear neat and comfortable clothes. Pay attention to the visibility of the PC, laptop, or mobile devices that you use to participate in the event. Pay attention to the ergonomic aspect of sitting position during the event. Do stretching every hour. Pay attention to any electrical hazards, especially on charger cables or switches around you. Stay healthy and follow the health protocol related to COVID-19. If you experience any symptom that point to COVID-19, immediately go to the nearest health facility. Make sure that you have enough internet quota or that your Wi-Fi is stable enough to participate in the virtual event until it is finished. May you have a wonderful virtual experience.
Assalamualaikum warahmatullahi wabarakatuh. Greetings to all of us. Om Swastiastu, Namo Buddhaya. Good morning, ladies and gentlemen. The Honorable Professor Dr. Heri Hermansyah as the Dean Faculty of Engineering, Dr. Paul Ramadhani Ardi as the General Chair of the 7th International Engineering Student Conference 2022. Our two keynote speakers, Professor Taufik from California Polytechnic State University and Professor Beni Cahyono from Coventry University. First of all, praise be upon Allah Subhanahu wa Ta'ala, God's blessings and grace that allows us to meet today. I am Prima, and I will be your MC for today's event. It's a great honor for me to be standing here and welcome each and every one of you to the 7th International Engineering Student Conference 2022, organized by the Faculty of Engineering Universitas Indonesia. Before we go any further, we would like to encourage all of you, the audience, to turn on the camera and use the virtual background. For of the 7th International Engineering Student Conference 2022, Engineering Student Conference 2022.
To Professor Heri, the screen is yours.
Good morning, Assalamualaikum warahmatullahi wabarakatuh. It is our great pleasure to welcome you, the guests and the participants in the International Engineering Student Conference IESC in Depok, Indonesia on July 6 to 7, 2022. This is the 7th series of IESC organized by Faculty of Engineering Universitas Indonesia with this year's topic entitled Promoting a Resilient Post-Pandemic Recovery through also Industrial Engineering. Especially for this year, IESC 2022 covers one of the most important topics that everyone might discuss in the recent time. How could the industry and business recover after pandemic without harming the environment? Hence, the topic of green technology and circular economy come into discussion and become very important. IESC 2022 aspires to become a place where engineering students could engage with such discussion and important and prominent discussion and hopefully also a fruitful one. After this conference, I hope that we could move forward in supporting the recovery of our society in the post-pandemic era, especially promoting the development of green technology and circular business alternative for our stakeholders, government and industry. I would like to express our utmost gratitude to the parties that helped IESC 2022, especially for our esteemed keynote speaker, Professor Taufik from California Polytechnic State University and Professor Beni Cahyono from Coventry University who would share valuable knowledge with us. Also, I would like to thank to all participants who would present their research in IESC 2022. By this conference, the standard of excellence of the student in developing technology in campus and also impactful research and innovation can brought together in this conference. I hope you will enjoy the conference. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Ramadhani, for the speech. We finally come to an end of our two opening speakers, and now we will be moving on to the next session. But before that, I would like to introduce myself. My name is Jay-Z, and with Prima, I'm gonna be your MCs for today's event.
Okay, ladies and gentlemen, we will now begin the keynote speaker session. Today's keynote session will be moderated by Dr. Engineering Radon Delika. Dr. Engineering Radon Delika is Assistant Professor of Department of Mechanical Engineering at Faculty of Engineering Universitas Indonesia. He has master's degree and doctoral degree at Tokyo Institute of Technology, Japan. He has previously worked in National Instruments, Singapore as Technical Sales Engineer.
Mr. Radon also received JASA Follow-Up Research Fellowship at 2018, Asian University Scholars Award at 2020, Research Grant by Osaka Guest Foundation of International Culture Exchange at 2021, and recently has received Erasmus Teaching Mobility to Sabancı University in Turkey. His recent research are about development of a motorized hospital bed with serve drive modules for holonomic mobility and shock, and also harmonic response analysis of UAV nose landing gear system with air damper in 2021.
To our moderator, Dr. Engineering Radon Delika, the session is now yours.
Right. Thank you. Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
My name is Radon, and I'll be the moderator for this session, in which we will be joined by keynote speaker of today, Professor Taufik. So let me first say hello to Professor Taufik. Hello, Prof. Taufik.
Hello. How are you?
Yeah. How are you today, Prof. Taufik?
I'm good, thank you.
Yeah, is it good morning or good evening there?
It's evening.
Yeah, thank you very much for joining us today. We do hope that your presence today and your sharing on this topic on post-COVID recovery will be very beneficial to us. So before we begin our keynote session, allow me to first read out his bio or CV. So Professor Taufik, he received his BS, MS, and Doctor of Engineering degree from the US, actually from several US universities. So his doctorate. He joined the Electrical Engineering Department at Cal Poly State University in 1999, and he is currently a tenured full professor and the director of Electric Power Institute. He received numerous teaching awards. Most notably the 2012 Outstanding Teaching Award from the American Society of Engineering Education. Currently, he has been and still is currently a senior member of IEEE, and he has a lot of industrial experiences with several companies. So to name a few, Capstone Microturbine, Rockwell Automation, some big names here, Picker International, San Diego, Gas and Electric, etc. So I think it needs no further explanation on his professional accomplishment. It's really a pleasure for me and us today to have him share his thoughts on the topic of greening the technology for post-COVID-19 recovery. I do hope that this will be a good opportunity for us to gain insight from his past experience in industry as well as in academia. So without further ado, Professor Taufik, the stage is yours. You have about 35 minutes to present your thought on this topic.
All right. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon or good morning. I believe it's still morning there, right? So good morning, everybody. And thank you for the introduction. And it truly is an honor to be invited here to share a little bit that I know about a topic that would relate to the theme today, which is the greening technology post-COVID. As already explained, my background, my training is electrical engineering. And so my presentation today would be something that would be directly related to my background. Because when we talk about greening technology, it is really a big and wide topics. And hopefully something that I would present today would trigger some interest among the audience here, faculty as well as students, to be able to join or at least initiate some contacts with you through this presentation. Hopefully together we could do some kind of collaboration or some kind of a partnership in the near future. So I would go ahead and share my screen. Let's see if it works. Hang on. Share. Okay. Can you all see? Can you confirm?
Yes. Yes, Pak.
Okay. All right. Very good. Thank you. Here. All right. So again, the theme of the conference today is greening the technology for post-COVID-19 recovery, and I would like to touch on something that relates to my background that would definitely support the objective of greening this technology for post-COVID, and that topic especially called hybrid AC/DC house, and I believe this is the type of house that would not only be able to improve sustainability of residential systems, but also in general support the goal of this thing, which is greening the technology post-COVID. And again, my name is Tafik, very short name. Just a quick introduction to my institution. I'm sure not many of you are familiar with Cal Poly. Cal Poly is short for California Polytechnic State University, which is originally a polytechnic school, but then it got converted into a university in 1972. We're about 22,000 students currently, and these are the different colleges inside or within the university, with engineering being the largest college in the university. And location-wise, this is the U.S. right here. You can see the map of the U.S. right here. We are in California, which is on the west coast, right, of the United States. And if you look at California by itself, we are actually located in the area that's called Central Coast, right here. So if you move on to the most left picture right there, if I zoom into the Central Coast, that's the city of San Luis Obispo, where the university is located. And we are in between two industrial areas, Silicon Valley to the north of us, and Los Angeles or Southern California to the south of us. So we are located in a strategic place, and we are also close to, like I said, two different industrial areas in California, big industrial areas in California. Here's a picture of the campus itself, a beautiful campus, as you can see from this picture, surrounded by rolling hills, and the beach is only like 15-minute drive from the campus. So I would like to extend invitation to all of you, if you get a chance to have the opportunity to visit the U.S., more than welcome to visit our campus. These are a list of people who have visited the campus. I won't go through those one by one, but I have had some faculty members as well as students from Indonesia to visit and do a short-term research in my lab, as well as some people who are just there to visit and explore collaborations with Cal Poly. So that should be enough for introduction. Oh, sorry. It jumps to the very last page. Let's go back to the initial or first page. And so, let's see. There it is. These are the outline of my presentations today. I will start with future sustainable net zero energy homes, and then I will explain problems with the AC system that we have today, and then I will also talk about the needs to complement the AC with DC, and then explain a little bit about proposed solution, challenges and opportunities, and I'll close it down with a summary of the presentation. All right. If we talk about technologies for post-COVID-19, I would say at least we should have these three characteristics, right, of what we need to improve upon. First would be accessibility, right, resiliency, and then sustainability. Right, these are the three things that I believe, at least we should be improving after we have had this crisis through this pandemic, right, the past 2-3 years. And I would say that COVID-19 served truly as a catalyst of some of the technologies that we had, prior to the pandemic. And one of the examples of technologies that would be moving faster because of pandemic would be the net zero energy homes. Right? This is a very good example that showcase the crisscrossing of many disciplines, not just engineering, but also other disciplines, right? Non-engineering type of disciplines. Within engineering by itself, for example, we could take a look at how we can achieve, net zero energy homes in terms of improving, building and insulation materials, architecture of the house, lighting design, sensors, ICT technology, controls and cybersecurity of the house, energy sources, energy storage, and lastly, electrical system. Right, so that's a lot, as you can see, to cover just from this single entity, right, if you will, right? And then, again, since my background is in electrical systems, today's presentation, I would focus more on the electrical system. Right? I could definitely do another round of presentation, maybe after conference to talk about maybe energy sources or energy storage type of the or aspect of the house. But first of all, let's take a look at what net zero energy homes is. So NZEH is a grid-tied energy efficient house that produces as much renewable energy as they consume over the course of a year, resulting in a net zero energy bill and a carbon-free home. Right? And as I said earlier, this house, the goals would have to combine the different aspects of the components of the house, and that would require advancing technologies for these different aspects, right? But in terms of the energy source, this, at least nowadays or currently, I should say, this house would rely mostly on solar panels as the alternative renewable energy source. And one way to achieve NZH, right, again, different technologies that would support the accomplishment of, or that would support the formation, establishment of net zero energy homes would be having a smart home, right? That's just again one way to achieve that. And if you look at smart home, right, a smart home, as you can see from this picture, would integrate different technologies as well, sensors, intelligent devices, ICT technologies, you name it, right? And as well as energy storage and loads. And now that we know the definition of net zero energy homes and one way to actually achieve net zero energy homes, then this actually brought me to the idea that, or the thinking that if we keep using the existing AC legacy system, like we have today, if you keep using AC system like we have right now at our house, then I would say that I would argue that it would make it more difficult for us to achieve this net zero energy house, right? And then that would slow down, the greening technology that would be the theme of this conference. So that's kind of the tie between greening technology and hybrid AC to DC. Hybrid AC DC is that if we keep using the existing AC system, then it would be making us more difficult to achieve this net zero energy system, net zero energy house. So then, why is it that I argue that it is going to be more difficult with AC system that we have today? Well, one thing for sure is that AC system is not going to go away, right? Electrical systems, as you know, are predominantly AC systems, and to get rid of AC is, I would say, it would not be practical, right? It would not be economically viable, right? So what can we do? Well, before we talk about it, then let's look at problems with AC, right? Power conversion loss is one of the problem with the current system, right? If you have, in your house, you have this AC wall outlet, right? A different shape here in the US, but you get the idea. Different country will have different shape of the wall outlet, but there is AC source right there. And let's say that you have smartphones, right? And a smartphone is a DC load. And in order for us to be able to use AC energy from the wall outlet, we have to convert it to DC, right? And that's why we use this adapter. And unfortunately, this process, going through this process would cause between 17 to 35% loss, power loss, right? The fact that we have to convert from fluctuating current to DC current, that would impose, power loss on the process. And if you think like 17 to 35% is not bad, this number that I gave you is not that bad. Well, let's put this into perspective. Let's say that I reduce the number of loss instead of 17 to 35. Let's make it 5%, right? Now this is even a low number, right? 5% compared to 17%, that's much lower, right? So let's see what happens if this process only causes 5% loss. Forget about the 17 to 35. Just stick with 5%. What's going to happen? Well, let's just take a look at one or two examples here. Let's say that I use tablet, right? And let's say that on average, right, a tablet will consume 12 kilowatt hour per year. And in 2016, there were 760 million tablets around the globe. So if you multiply 5% loss to this number, then you get roughly 480 gigawatt hour per year of power loss. Energy, right? Energy that is being dissipated here within the converter, right? So that's not a small number anymore, right? 5% translates to 480 gigawatt hour per year, right, of energy being again processed through this converter, right? Now, if I use another example, a smartphone consumes about 4.2 kilowatt hour per year, right? And there are about 2.71 billions in 2019. Go ahead and do the math. You can multiply the 5% by these numbers, and you get about 599 gigawatt hour per year. So you can see that even with the 5% loss, these numbers translate into huge amount of energy wasted, basically, right? And if you add the two numbers, right, just from these two small gadgets, right? If you add these two numbers, right, then it's going to amount to an equivalent of 12 units of 10 megawatt power plant operating 24/7 for the entire year. So, talking about green technology, this is definitely not green, right? Having this 5% loss, right, is not really what we want to achieve in the near future. So that's one problem. Another problem with with AC would be that AC is harder to control than DC, right? In DC, we have only one type of power, which is watts, whereas in AC, you have to deal with many types or several types of power, such as instantaneous power, average or active power, reactive, complex, apparent power. In DC, we don't have to deal with this type of type of power. And another thing about AC is that there is this thing that's called power factor, right? And therefore, it would require in AC system, it would require some kind of a reactive compensation, unlike DC. And so those are the two major problems with AC. Again, if we stick with AC current existing AC system, I don't think we could achieve the net zero energy house, in short time. So, so therefore, we need to somehow complement, the AC with the DC, right? Now, why DC? Why DC? Well, if you look at these three graphs, I'm not going to go through these in details. One of them is smartphones. I already mentioned smartphones. You can see that smartphone inside is a DC operated device, right? So it's not an AC device, it's actually a DC device. And look at the numbers of cell phones or smartphones by 2021. It's almost 2 billion units. Right? If let's say just leave it as 2 billions, right? And let's say that when you charge it, right, the cell phone requires 5 volts. And let's say when you're charging it, it requires 5 volt at 1 amp. And let's say it takes about 1 hour to charge it, and times 2 billions, then you can see the amount of energy that is required to be processed through DC in your house, right, globally. That's 10 gigawatt hour. That's not a small number. If you look at LED lights, right, same thing, LED lights are DC, they're not AC. You can see that the number is exponentially growing, right? And again, multiply these numbers, and you can see how much power in our house is being processed through DC. Right? It keeps growing. And another reason why I believe we need to complement DC with DC is because of the technology that we have today, such as USB Type C. Right? There's of USB Type C, but one of them that I am very excited about is that USB-C is targeted to be able to provide up to 100 watts of power. So imagine, right, USB-C can provide 100 watts. Imagine how many DC loads we can actually power through USB-C in our house, right? And again, USB-C is a DC type of component. Right. And I've run a little bit of statistics here in the U.S. Of course, in year 2000, if you looked at the mix of AC versus DC loads, right there is about 20% back in 2000. But in 2018, that number grows up to about 30%, right? And so that's a 10% increase in terms of the mix between AC and DC, right? So DC becomes more now. Right, in the house in the US. And I would argue that a country like Indonesia, for example, the mix would be actually higher for DC. Right? The reason why AC is still big here, 70%, because in the US, if you've been to the US, you probably are familiar with the fact that we like to have big refrigerator, big air conditioning, right? Big washing machines, right? These are all AC loads, right? Big AC loads. Whereas in Indonesia, we have smaller type of AC loads. So I would argue that the DC loads percentage mix in Indonesia will be bigger. All right. Why again need to complement with DC? Because nowadays we have these solar panels, right? And the solar panels sitting on top of our house, right? Rooftop solar panels, and they are producing DC. Right? So now we have not just the loads that are DC, but also the source that is DC as well. Right? So if the source is DC, the load is DC, then to me it makes sense that in the middle we should just have DC to DC, rather than doing what we have currently. Right? This is what we're doing now. Right? We have a DC source, which is our solar panels. outputting DC, then we convert it into AC. In the process, you lose 23 to 28% power loss. And then from there, after you convert it into AC, then you have to convert it back down to DC. That's again a 17 to 35% loss. And then in order to match the DC voltage, you have to have another DC to DC again with some loss as well. I would say about 5% loss or so. Right. So again, I think the top solution should be making more sense than the bottom one. Right. And another reason why I think we need to complement our current existing AC system in the house with DC is the fact that at least in the US, right, I'm pretty sure it's also the trend is also the same in Indonesia, is that more and more people are putting smart devices, right, such as security cameras, smart locks, motion detectors, what have you, right? And these are all DC operated devices. And lastly, I don't know if this is the last one. No, yes, it is. Another reason why I think we need to complement with DC is that eventually, right, once you have the solar panel and you connect it to PLN, for example, then you need some kind of a energy storage system, right, to be able to complement the sources, just in case there is excess energy from the sun, right, produced by the solar panels, so you could store it in this energy storage, right? And as you know, energy storage systems are also DC systems, right? So that's more, these are more reasons why I believe, house in the future should be complemented with DC. And this is what I've been proposing to do, is that in the future, we should, our house should have a hybrid AC/DC electrical system, where, for example, you have incoming energy from PLN, which is AC, and then let's say you have rooftop solar panels, right? And then you have, instead of just AC system, AC bus running both AC and DC loads, why not separate the two, right? So you have AC bus and DC bus. So AC bus is powering AC loads, DC bus powering DC loads. And not only that, we should be able to provide some kind of a crisscrossing pathways where AC could support DC in case there is not enough energy from the sun. Then you can complement it with AC, so you can see there is a path from AC to DC. And likewise, if there is, if let's say there's a blackout, right, and if there's enough energy, then the solar panels, for example, and associated battery, could supply not just the DC but also to AC, as you can see from this path. So that's the idea behind hybrid AC and DC, right? And you can also add more and more energy sources here, not just solar panels, right? And if you look back into this picture right here, one of the key technology is what I call MISO, right? MISO stands for multiple input, single output, right? And this technology by itself, I've developed since 2010. This is the idea that I had, again, in 2010 of what I call the DC House project, right? And so in the DC House project, the goal was to help access of electricity in rural areas. And in this case, I'm interested in putting or connecting small DC sources, not big ones, but small ones, combine the energy into a bigger energy through this MISO converter, right, into a DC bus, 48 volts, and then the house itself is purely DC. But again, this is only good for off-grid type of application, rural areas away from the grid, right? But for urban areas, of course, you can do hybrid AC/DC. But again, this is the backbone, one of the backbone technologies of the hybrid AC/DC, right? Is to use this technology right here. Right? And I won't go through this, but these are pictures of DC house prototypes that exist around the world. We have 4 so far. One at Cal Poly, one at Pajajaran University, and one in Philippines, and another one in Jatinangor Regency office, in the office building there. We combine wind and solar panel into a DC bus system inside the office. Right? All right, so let's talk about challenges. Let's see how much time I have. Not much. And so there are a lot of challenges and that we face in this development. But to me, challenges present opportunities, right, for new technological development, which further on bringing innovations, right? So some of the challenges that I've observed would be the first one is limited DC sources and maximizing the use of renewable energy source, right? This is even more important in areas where AC grid is not reliable, right? So imagine if you could add more source into the house, into the hybrid AC DC house, that would be awesome. And then also making other renewable energy sources adaptable. Right now, solar panel is the most dominant source. What if we can also integrate, some kind of a miniature, wind turbines or what have you? Right? MISO converter needs further development for commercializations. DC bus and loads are not standardized, unlike AC. And another thing is that DC, one of the drawbacks of DC is that it is more difficult to protect from faults than AC. And when you connect more sources, of course, there's going to be some strict regulations to prevent backfeeding power into the grid, right? To make it safer for the crews who utility, who are trying to fix, for example, down power lines. And another aspect of hybrid AC/DC house would be EMS, right? Energy management system that would be able to coordinate different sources and loads, right? To work with each other in a more streamlined way. All right. And yeah, these are just some examples of what you can do in terms of the sources, right? I've developed, for example, a way to use car alternators to make it low speed, make it cheaper, right? And then play park generators, right? And then miniaturized hydro or wind turbine. Right? These are not mine. These are all commercially available already, right? But that's just some ideas. And another thing is that adaptability, right? I mentioned earlier that solar panel is the most dominant. Why not use the other ones, right? Well, for example, here the problem with wind turbine is that it's ugly, right? It's big and it's noisy, right? And think about how we can actually adopt this technology, right? It'd be great to be able to tap into wind energy, not just solar panels, but also wind energy. But if you use this approach, then people would say NIMBY, not in my backyard, because it's ugly. It's not it's not pretty to look at. So then why not make something like this, right? More aesthetically pleasing, right? So you can see we have this wind energy generator using fake tree, this one and that one as well, right? And then you can also have a more artistic design, right, for wind turbine. That way is more like I said, aesthetically pleasing than this wind turbine, right? So think about different ways of adopting wind energy as well as hydro power for the AC DC house. And as I said earlier, EMS is another problem, a challenge that we have not yet addressed. And if you're interested in doing this, more than welcome to do that. Right. I would skip this one. And this is just to show that the MISO technology, we finally found a key to do this, to combine different energy sources into one. And we just had the patent back in 2019. That's the patent that we received on the MISO. And another problem with I mentioned about DC is that it is not standardized, right? In AC, in your house, for example, AC is standardized 220 volt AC from the wall plug, but in DC, it's not standardized. So we have loads that are running 9 volts, 12 volts, 15 volts. So it is not wise to have multiple wall plugs, right? Imagine you have multiple wall plugs for DC. So what can we do, right? Well, one way is to develop smart DC wall plug. So imagine you have a smart DC wall plug. So it outputs DC, but then it would be able to adjust the DC output voltage. So depending on what you plug in, it would be able to recognize and then output the appropriate way to. So at Cal Poly, we develop this as well, and still not optimized. So if you are interested in developing that with us, let us know. I'm gonna skip ahead. There's so much that we can cover, and unfortunately, I'm running out of time. With the hybrid AC/DC, you could definitely network more than one house, and this will be very good for alternative solution for rural electrification. Right, this is what we have currently. Right, I'm not saying this is bad. I'm saying we need to complement this, because one size doesn't fit all when it comes to rural electrification. Right, and with the proposed solution right here on the right side, this is what I'm proposing. I can argue that this is more reliable than the existing technology. Again, I won't go through this in details. I actually have some examples that shows that this is actually to prove or to demonstrate that the proposed solution is actually more reliable. So I'm going to skip this. If you have a question on it, then you can ask it later. All right. What else can we develop with hybrid AC/DC for future, green technology? We can start developing DC loads, because DC loads are still limited. So that would provide opportunity for us to, develop more technologies for DC loads, right? A lot of stuff you can develop here: DC air conditioner, DC water filtration system, what have you. Right? I won't go through details. All right. So. It's a huge undertaking, and we're not even halfway, between the starting point and the end point. So if you are interested in helping us in establishing, hybrid AC/DC for future net zero energy building, let me know. And here's a prototype of a hybrid AC/DC house that I have at Cal Poly. We just finished this couple months ago. These are actually AC/DC hybrid system, right? And if you're interested, again, I can definitely talk about it in some other event. All right. I would like to provide opportunities for question and answer session. So therefore, I'm going to close it down with some summaries of what I presented. The first one is that I hope that I convince you that there is a need to explore, DC to complement the existing AC residential system, right? AC is not going to go away, but our best bet is to complement AC with DC, right? And by doing so, we promote the use of renewable energy. Again, this is under the theme of green technology. Maximize system efficiency when DC loads are continuously growing, and this would help achieve, the net zero energy houses. DC has technical challenges. However, view this as, opportunities for us for new solutions, as well as innovations and business opportunities. And I also mentioned a little bit about how the hybrid AC/DC could also improve access to electricity. I skipped the example, but, the house could actually improve reliability of the electrical delivery for, houses in rural areas. And I believe that hybrid AC/DC house would be the future of residential house, right? So we need to move fast to be the leader in this new field. Otherwise, we'll be, just following other people as other countries, in this development. So we need to move fast to jump in the train and, develop, these different type of technologies that would be required for hybrid AC/DC to achieve the net zero energy house. Again, it's a lot to explore, from not just from technological aspects, but also economical, environmental impact, social effect, and so on and so forth, right? And with that, I would end it with this page. If you're interested in the DC house, that's the website, and there's my contact info. And that would be it. Thank you for listening. I hope that you can learn from the presentation. Thank you.
All right. Thank you very much, Professor Taufik. Very exciting talk indeed. As a quick summary, I think Prof. Taufik mainly explained about the problems of energy loss due to AC/DC conversion mainly, I guess. And that's why he proposes the concept of net zero energy home, DC house, and I think there are a lot of opportunities for DC among other things. Yeah, I myself learned a lot because I think Prof. Taufik explained the concept very well, very simple and easy to understand. Although my background is mostly from mechanical engineering, but I was convinced about this need of, I don't know, I think slowly, adopting these DC technologies, right, to move forward toward DC. All right, so I think without further ado, we are opening the floor for Q&A sessions. So is there any question from the audiences here? So I would like to welcome anyone. So yeah, there's a raised hand here from Mr. Is it correct, Mr. Itsnanta?
Hello, yes. My name is Itsnanta. Actually, first of all, thank you, Prof. Taufik, for your very interesting topic and presentation. Smart home as one of the way to achieve net zero energy home. Facing some concern on the common AC system, the hybrid AC/DC as the solution to have more efficient and green energy. So my question is, could you help to elaborate more the roadmap and also the expected target for the deployment, and also this solution can be implemented, especially in Indonesia, so more people can enjoy this very great innovation, I think, yeah, Prof. Taufik. Thank you.
Thank you, Pak Itsnanta. So I think the exact question, we are all curious about the projection. So what you have in mind about increasing this adoption of AC/DC house and its technologies? Please, Prof. Taufik.
Yeah, thank you. Very good question. Yeah, this is indeed an issue that we have to address together, especially if we would like to adopt this technology soon in Indonesia. And that has been the problem, of course, right? Anything to do with new technological development, yeah, it's not easy, right? It's not, the engineering aspect of it is a challenge, but what comes afterward is also another challenge, right? How do you actually make this technology being accepted, right, or adopted in an area or a country, what have you? So roadmap wise, I don't have the definite timeline in terms of deployment. This is really up to many sectors in Indonesia, right? Academia, what do you call it? Research agency, government, research agency, as well as private sectors, investors, to be able to hopefully be sensitive enough, or I would say aware enough to grab this opportunity, right? And I've been promoting this, since 2011. Just to give you an idea, right? It's going through a lot of, frustration, of course, that unfortunately, the very first country who was interested was not Indonesia, but it's actually Philippines, right? So you saw that picture there earlier, that Philippines was the first country that reached out to me and asked me to actually develop a DC house for them, right? Starting from that university. Now they are expanding their DCR technology in one of their islands. Indonesia, unfortunately, from what I know, I'm not sure what the problem is. I'm being in the US, I don't really know the exact problems of why not many people are, I don't think they're not unaware, but I think there are a lot of interests, but there's definitely something that would, resist, from having some kind of new technology in their in their new deployment of, for example, rural areas, or whatever, the different areas of different industrial aspects of technology that they could easily adopt it, but somehow there is no follow-up yet. I don't know what the proper word to say, but the very lack of follow-up. I think that's the answer to that question. So that's why I would hope that from this presentation, there's more and more people who become aware of the problems with AC, and hopefully by spreading the words, Indonesia would be able to be the leader of this technology. So unfortunately, to answer your questions, I don't have any roadmap right now. My mission is to make people aware of the fact that we have a problem with AC, and it is time for us to start thinking of not changing, but adopting DC, right? Developing DC, not just in our house, but also in many other electrical systems, right? This is just a portion of it. So yeah, no roadmap for deployment yet. This is still in the phase of, making people aware, educating people, if you will.
Yeah, thank you very much, Prof. Taufik. No roadmap yet, meaning a lot of problems, but as he said earlier in the talk, problems or challenges mean opportunities, right? So this can be translated, and we can think of it another way as opportunities for all of us in Indonesia, I guess. So moving on to the next question. So here we have with us Mr. Muonge Martin. So he's one of our overseas participants. For today, Mr. Muonge is from Uganda. So please, Mr. Martin.
Yeah, thank you so much. I would like to appreciate Professor Taufik for the presentation. It is really nice and educating. Indeed, I have one question to pose to the professor. Is this technology applicable to other homes that are not smart homes, or it is only relevant, or it can only be applied in smart homes, because not everyone stays or lives in smart homes? What is your take on that, Prof? Thanks.
Yes. So yeah, it doesn't have to be a smart home. Smart home is there. I mentioned smart home because I think in order to achieve net zero energy house faster, right? Accelerate the goal of having a net zero energy house, I think it is necessary to have a smart house, but it is not required, right? So in order for us to be able to, for example, adopt a hybrid AC/DC, you don't need a smart house, right? All you need is having additional electrical system in your house. You branch it into two different buses. If you have one single AC line from the grid, you can just branch it into AC and DC buses in the house. Or if you have additional source such as solar panels, then just like the picture I showed you earlier, you could have crisscrossing paths between the two electrical systems. So yeah, you don't need a smart house to be able to have a hybrid AC/DC, right? So it is not a requirement. And by the way, still related to the previous question, it's actually easier to test this kind of technology in Indonesia, right, than in the US. In the US, there's a lot of restrictions, a lot of regulations. So I could not just test hybrid AC/DC in my house, because then I would lose insurance, for example, or I would violate some laws or some rules. And so that's why, again, it's still puzzling to me that this type of technology still is not taking off in Indonesia. And I need your help, to be able to educate more people, spread the words, and so we can have a clear roadmap and deployment in Indonesia. So I have to go back to the previous question.
Yeah, thank you so much. I think that's one good news for every one of us in Indonesia. So I think according to you, implementing this hybrid AC/DC house is much more easier in Indonesia than in the US because we have much less restrictions, meaning less regulations, etc. at the moment. Right, so a lot of opportunities for, including the one asking question just now, Mr. Muangi. I think maybe we share some similarities between Indonesia and Uganda as well. Right, Prof. Taufik, I think our participants are very, very enthusiastic about your talk. We received a lot of questions, and now I'm trying to read this question from the chat box from Mr. or Miss, I'm not sure, Belijan, how to integrate to other systems, building and transportation, if it is implemented in big cities such as Jakarta. So maybe you have comments on this.
Yeah, of course. You heard about smart cities, right? And you have all of these sensors, be able to come up with more efficient, more effective transportation systems, not just from the management point of view, but also scheduling, but also from the fact that you could actually generate power by moving vehicles, right? And you've probably seen some examples where they use the moving air from passing vehicles and convert it into energy. And to me, it would make sense, right, if that energy is in terms of DC, not AC, right? Because those type of energy harvesting, if you will, technology, these are not big type of energy, right? These are all smaller type of energy source, and it doesn't make sense to convert it into AC. Right, you have to, in my opinion, it will be more effective to use these DC. That's one aspect of it. And what about, for example, electric vehicles, right? Or not electric vehicles, sorry, mass transportation, right? You have to connect, for example, maglev, what do you call it? Magnetic levitation system, right? Or the train itself, right? There's a talk about having a pure DC system inside trains, for example. So that actually proves the point of that everything now is going to DC, because again, it is the most efficient way of processing energy these days, right? So I don't know if I answered that question, but how do we integrate into transportation? There's different ways, as I just explained, right? From management point of view, logistics, energy harvesting, from powering the what do you call it, the vehicles, right? Trains, buses, through energy storage, right, and so on and so forth. So many ways. I don't know. Hopefully that answers.
Okay, thank you very much. Yeah, hope this answers the question. We are sorry, but we are running out of time because the session should end now, 9:45. But before we end, I would love to hear maybe if there is any motivating words from you to share with our participants, because most participants of today in this IESC are our students, undergraduate and postgraduate. So Prof. Taufik, would you love to share, I don't know, like 1 minute motivational words to share with them?
Okay, sure. Let's see. I talked a lot about challenges, right? I think again, I would invite my fellow faculties, first of all, and also students, especially students who are in the audience, to again look at these challenges as opportunities, right? And we try our best, of course, to find different ways of answering these challenges. But I think students, the young minds, right? I would say they would probably can come up with much more creative solutions than my generation. So keep looking for alternative solutions, right? I'm a Muslim myself, right? And you've seen verses in the Quran that says to just look around you and look for challenges, opportunities around you, right? And that's what I usually do when I commute from my house to my campus. I usually drive 30 minutes, from my house to my campus. And while I'm driving, that would make me that would provide me with some opportunity to actually look for ideas, look for challenges, look for opportunities by just looking around. Right. For example, that fake tree that I showed earlier, that was my idea back in 2009. Right. When I look at that fake tree, it was actually for cell tower, for cell phones. Right. But then as an electrical engineer, I try to think out of the box, and then I was like, well, how can I make a fake tree as a tree that can generate wind energy, right? And so that's why I decided to develop this technology where we can convert, for example, from a fake tree to energy using piezoelectric. Right, and so we developed the circuits back then in 2010, and we did that. So again, never stop looking for opportunities, right? And again, don't be afraid of challenges. I would say, right, because challenges means opportunities for us. Right? That's all.
Again, thank you so much for your sharing today, Prof. Taufik. Before we end, we would like to give an certificate as a token of appreciation for your sharing. So here is it. And we are also going to take a photo. So to the MC.
Thank you.
So please direct us about the photo taking as well. Is it already done?
Okay.
Yeah, okay.
Okay, like the moderator said before we split into another exciting session, let's make today's event more memorable by documentation. So all participants, we would like to ask all of you to turn your camera on so we can take a picture together.
Yes, and we will wait for 1 minute. So
that
all of you, if you want to prepare yourself for the best look,
picture for
yes.
today.
We will wait for 1 minute.
Okay, first slide. Next.
Okay, next for the second slide.
Second slide. Next, third slide.
Okay.
Fifth.
Okay.
Okay.
Thank you so much for.
Okay, so with that, I think let me hand back to the MCs for the next session. Again, thank you very much, Prof. Taufik and everyone. Assalamualaikum warahmatullahi wabarakatuh.
Okay. Thank you so much, Professor Taufik, for the incredible and insightful presentation. And also, thank you very much to our wonderful moderator for leading today's keynote session.
As we said, next we will continue to our main agenda in the 7th International Student Conference 2022. Our presentations are conference parallel sessions. The committee has already scheduled all papers into several parallel sessions. We would like all participants to consult your schedule and also join the breakout room in accordance with your sessions. Thank you.
Thank you.